Live.
Okay, it's live now.
Okay. All right. So, like I said, a lot of the same stuff. Did you did you able to pull up box plots? You know, it showed that in the homework stuff, and I'm thinking we don't have like a template for that, so I googled it online. But the box plot that's shown in our homework assignment, like this thing right here, they're like they're this way, and the box plots that I pulled up online are this way. I mean, they read the same way. It's easier to look at them when they're lined up like that.
Yeah.
But anyway, okay, ready to go to the test?
Yeah.
Okay. Start quiz. All right. True, true.
Yep.
Okay, soccer. All right, soccer shoes and hot dogs. Okay. Okay, hot dogs, hot dogs, hot dogs. DHDALS. Hot dogs. Some of these studies are, they're pretty cool.
Yeah.
I like the one where you're the grateful one. You know, that was a neat. I like that. That was really cool. To test and see which people are more happy in the world. Okay, so in a ANOVA hypothesis test, we reject when there is sufficient evidence to indicate at least one mean is different from the other. I just want to make sure. I think it's true, but I just want to clarify.
I think it is too.
You think it's true too?
Yeah, but I'm not positive.
Okay, let's see. Because a null is all means are equal, and an alternative is one or more means differ. So we reject the null when there's sufficient evidence to indicate at least one mean is different. True. Okay. What requirements needed to be checked before making a hypothesis? Okay, mark all that apply. I wrote all this down. So if mean differ in comparison concludes means are not all equal.
Variances are equal in each group. It's one of them.
The variances are equal in each group.
That's what one of them is. I don't know.
No, you know what? Where is it that said something that these were all negative? So it's definitely not sample means are all positive. I think they're all negative.
I think they're negative too.
I read that somewhere. Oh yeah, values of F are negative.
Okay, so that one's not right.
And right skewed. P-value is in the area in the right. Never mind. Okay. Data normally distributed in each group, so that's right. Number 2 is right. Variances are equal for each group. That's right. Okay, first, the last two.
Each group is number 2 of following.
Okay. Number 5 is the QQ plot.
Yeah.
The variance in each group is the same if the following happens. Okay, I wrote that down too. Okay, so the variance needs to not more than 4 times. So the largest variance is
less than 4 times than the smallest.
Yeah. Wait. Yeah.
The second one.
Yeah. Yeah, the largest. Okay. Yeah. And then is equivalent to conducting two sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 2, 3. How many pairs? 4 samples. All right, we just have to do some calculations here. You have 4 samples. 1, 2, 3. 1, 2, 1. Would you say they're 6? You have to do 1, 2, and then 1, 3, and then 1, 4.
4, yeah.
2, 3, 2, 4, right?
Yeah.
You have to do 3, 4.
Yeah.
So 6, right?
6.
Sounds good to me. Okay, here we go with this nonsense, and it better work right. The data was collected to determine how the design of soccer shoes affect the accuracy of kicking. Okay, we did this one in the other thing. There are 5 types of shoes labeled A, B, C, D, E. Also wearing socks tool. Each represents a kick. Okay. What's the minimum variance for the 6 groups? Okay, let's figure that out.
Ugh. Stupid thing.
Okay. All right. Are you pretty good at spreadsheets?
Yeah, but these ones don't work very well on my computer.
My husband just taught me how to, because I was like going through and like, he said, no, you can sort by stuff. And he showed me how to sort it. And I thought, oh, honey, where have you been all my life? You could have been, I could have been doing this so much easier with your help. He's really good at them.
Well, my mom, she's a computer like person.
Oh, wow.
That's her job. So
That's great. Great resource.
So I just go to mom when I don't understand.
Okay, I've got them plugged in now.
Okay, I can get it to work.
Okay. I'm going to label them A, B, C, D, and then E is actually socks, aren't they? Okay. So according to my thing,
Smallest variance for 6 groups
is 27.208.
7.208.
Mm-hmm.
Oh, what is the maximum?
The maximum is 53.158. And that better be right.
It better be. The test for equal variance is satisfied for these data. This is very awful English.
Okay, hold on a second. I'm gonna write this. I've got to get my little.
Oh, you're good.
Yeah. Okay. All right. All right. So the test for equal variances is satisfied. These data. Oh, that means that they're satisfied because they're not 4 times more.
Yeah.
Right.
Construct a QQ plot for each of the 6 samples.
Okay.
Each of the samples are approximately normal based on what you see in the QQ plot, true or false.
Okay. All right. Well, we can do that. Let's see here. Where's my thingy? Boink. QQ plots. Those things are fun. Okay. All right. So I'll clear the data. All right. Group A. All right. Group A is to me looks normal.
Okay.
Pretty normal. Group B. Group B. Kinda. They're hard. I don't know what I'm looking for, but yeah, they're group C. Yeah, that one's kind of weird, but it's somewhat normal. Okay, this one. They're very much so. Group C is very much so. Oops. Ah, dang it. Okay. Oh, definitely. Group B is very much very good. So then what was kind of weird was B. This one is socks. And it is. So yeah, all right.
That's true.
Let me look at B real fast again.
Okay, because it just says approximately normal based.
Okay. It's 30, right? All right, let me just look at this one here. Yeah. Ish. Well, you know what? We'll put true. If it's not, we'll put false.
Oh, that's right.
On round 2. Because it's ish, you know?
Yeah. Perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value when we remove the SOX data?
Okay, so timeout. Okay, so what did they say the p-value was? See, that's not my p-value.
0.081.
It's not my p-value.
What? Ooh, no.
Is it yours?
I don't know. I can't get it to work online.
It shows mine is point 309. See, that's why this kind of stuff, I'm like, what the heck?
Perform an ANOVA test for SPSS. And is there...
Okay, we don't have SPSS, so we have Excel. So, and observe that the p-value is 0.8 less. That's not my p-value.
I have to go to class. Go feed my rats.
What if our p-value doesn't, the one that on here says it's 0.081 and ours is not that? On her Excel, it's not that.
Remember the socks that I'm performing the text again. And you have all 4 sets of data in there?
Yes, I do.
Huh.
Because if my p-value is not right, then my our variances are probably off, and then those other answers we got But see,
What's your p-value right now?
my p-value in this with all 1, 2, 3, 4, 5 of those is 0.309208508. So 0.309, not even close to what they say the p-value is in the question 12.
I would just erase all the data and then put it back in again.
Okay. So
Yeah.
just
Just because you might have like missed one because or like something like when copying and pasting. That happens to me all the time.
okay.
My group gets
Thanks, Mom. Have fun at class.
Thanks, Mom. Okay. So let me pull the soccer shoes back up. And unselect them. Select. Here's A. Okay, I'll try it again. Okay. And then get out of here. B. All the way across. Looks good. See? I mean, it's a copy and paste. I mean, my numbers are matching up with it perfectly. So here's my D. Boink. Okay, things matching up perfectly. And then get rid of that, do my E. Okay, matched it perfectly. Okay, so every number that's on my spreadsheet is on this thing, and my p-value stayed the same.
Oh my gosh. Ugh.
So help me figure that one out. It's on ANOVA. I'm on the right one-way analysis of variance.
Mm-hmm.
The data for each sample in a separate column, which I did. Let me take off. Hang on a second. I have my variable 6 up. Hang on a second. Let me see something really quick. I'm gonna erase this thing. Delete. Oh man. Okay, time out. Let me see something here. Out of here. Just delete. Entire column. Okay. All right. Because I have another like variable 6 up in this column. So what if I just erase this column?
Yeah.
You need to change it.
I mean, why not? See if it does anything
Okay.
to your p-value.
Go higher. When I do that, it messes up it keeps my things. Okay, hold on a second. So maybe I should, before I put the data in, I'll erase that column and then I'll put the thing in. So let me see something here. Maybe I'll get a whole new thing. Hold on a second. Let's see. Where'd it go? Where are you? Where are you? Pull up this other one here. Pull up a new one. Give me one. Oh man, look at this. Delete the whole column. Delete the whole row. Okay. Now I'm going to plug in what I had. Oh no, don't do that to me. Oh my gosh. Okay, can't breathe, can't breathe, can't breathe. Okay. Oh man. So we have to go through this thing again. Where is it? Soccer sheet. Pull up my soccer sheets. All right, let me try this again. I wonder if it'll make a difference. We'll see. Maybe it'll make a difference, and then
Maybe it will, but who knows?
we'll be so excited. Let's see. All right, here we go. Run it again. I'll do it. Try as fast as I can too. I'll clear what's the information in there. Maybe that's didn't clear it right. Okay, here we go. Starting from fresh. Okay, so I'm feeling good now. This is gonna be good. It's positive talk, positive thinking. Copy. Fast as I can. Not messing up. Data. Here's C. Get rid of B. Copy. Paste. Copy. See that kind of stuff? It's like you've done everything that's asked of you. No.
Yeah.
Oh my gosh. Okay. Okay, here's E. All right, all right. Okay. Okay. And the socks are F, aren't they? All right. Pull this up. Heaven help me, 'cause I need help. All right. Right there. Okay. Thank you for your patience. Okay. All right, we're trying this again. I'm double, triple checking. If not, I mean, it's just.
Just leave it blank.
And then we'll say, you know what? Do you like this class?
I don't like math, so that's probably my problem.
Oh.
Math is not my high quota of life.
Do you like reading?
Do I like reading? No. I like science.
Science.
I love science. I love biology. I love all that stuff.
Wow, very good.
I'm really good at biology and that stuff and science stuff. But math never came easy to me.
Yeah, I'm not really good at it, but I like it. But I'm not really good at it. So it's kind of
I'm neither. I'm not good at it and I don't like it.
Okay. We got a bingo. Okay.
Yes.
All right. Now we
can remove this offset.
You know what? It didn't change the variances at all. But it did change the p-value.
Okay, that's all that matters.
Yep, that's all that matters. Okay, so now the question was, read the question to me again.
Perform an ANOVA test in the SPSS and observe the p-value is 0.081. Then
Yep.
remove the SOX data and perform the test again. What
Okay.
is the p-value when we remove the SOX data?
Okay, so I'm gonna remove the contents of that. And now the p-value is 0.309. Okay, we got it. This is gonna be good.
Not what you had before.
Yeah, it was. So I must have left out some information. So
The test statistic for an ANOVA hypothesis test is an F statistic. Is a p-value with the area to the right or the left of the F statistic?
always to the right.
Right, yeah.
Okay, now we're onto the hot dogs.
Researchers at Consumer Report analyzed 3 types of hot dogs, namely beef, poultry, and meat. Gross. But up to 50% poultry and meat. For each of the 54 hot dog analyzed, they recorded the type, calories, and the sodium level.
Okay.
Examining the calories first, construct QQ plot of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use the ANOVA have been met.
Okay. So I'm gonna get rid of all this other stuff here. Let's see, clear. Okay, and then I'm gonna get the beef. Where's the beef? But you know what? There's only 21 samples. So what do they want? They want calories or sodium?
Yeah. Calories.
Calories.
Let's examine the calories first. Construct the QQ plot of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
Okay. All right. So let me look at the Q plot here. Pull this bad boy up. All right. QQ plot for this. Clear. Edit. Oh, okay. Cancel. Clear contents. Okay, the QQ plot for the beef calories. That's what I'm doing right now. Okay. They're okay.
Okay.
I don't like that, not completely straight, but they're okay. Okay, so let's go here. I want beef meat now. Okay. Oops, I gotta clear first. Contents. Okay. Clear. And let's see, ascending order. Yeah, not as much. Okay.
Yes.
All right. This one.
Sorry, that was me texting her back.
Oh, okay, yeah. Oh, here she comes. Is she coming on?
I think so.
Okay. Okay, so this one is even worse. So the first one was okay, the second one's not as much, and poultry is not as much.
Okay, and then it says, and compare the variances to determine if the assumptions to use ANOVA have been met.
Okay, all right. I'll plug in that. Hot dogs. Armor hot dogs. What kind of kids? This one's poultry, right? Number 3 is poultry. Poultry.
Yeah.
Tree. And I'm just doing calories because they have a sodium thing on here too, right? Just doing calories.
What the crap is happening?
She trying to get in?
I don't know. I'll figure it out just a sec.
Okay, 186.
I'll add her again.
So beef had 22, right? Are you guys lying? You can invite me. Oh yeah, she's asking you to invite her. Okay.
I'll do that real quick.
Okay.
I've got way too many things open right now.
Okay, yeah, so I'm up on this. Excuse me. So I'm trying to figure out if the thing has been met. Yeah, I mean, the sample sizes are smaller, but the variances are not 4 times the thing.
So they have been met?
Yeah.
Okay, and then it says, it's safe to assume each group comes from a normal distributed population from the Q plots.
Yeah.
And we can also assume the variants are equal, or while it's safe to assume each group comes from the normal distributed population, we cannot assume that the variances are equal.
Let me think about this for a second. The assumptions have been met, so it's safe to say each group comes from a normally distributed population from the Q plot. We can also assume the variances are equal. The assumptions have not been met. The assumptions have not been met. Ugh. Okay, I'm gonna say, well, because when we look at this, we have to look at a couple of things. We have to look at to see. But the QQ plots, they're not like, it's not a totally straight line. So let's go with the number 2 one. The assumptions, while it is safe to assume that each group comes from a normally distributed population, we cannot assume that the variances are equal. Because they were kind of. So I don't know. Did you add her? Rachel, did you add her?
Yeah, I'm here. Can you hear me?
Yeah.
Thank you.
Okay. Okay.
You hear me?
Yeah, we got you.
Okay. All right. I thought I was invisible. Sorry about that. I had a sick kid.
Oh, I knew something was up.
Yeah.
We're on the test. We're trying to figure out. We did the Q plots.
Oh.
And
okay.
they're a little weird. So we're trying to figure out what the question, to answer the question properly, is.
The test prep? Yeah. We have to do this week on Wednesday.
What's that?
We have to do the test prep on Wednesday, right?
Yeah.
Okay, sorry.
Okay, so where's back to the test? Let's see. All right. Okay, so the we can assume that the variances are equal because it's not the 4. We can assume the variances are.
What number are you guys on?
But it's not safe to do. We're on number 14. Just go with us.
Okay.
On the rest of them, and then we'll backtrack for you.
Sorry.
No, you're good. You're good.
He's like, where's Jen? She's flaking out.
Well, we knew something must have been up.
And I didn't have a phone, and I realized at the office, I was like, oh, man. I should have just had my husband take him, but I wasn't thinking. Okay, number 14. Q Club. Let me download that.
So let's go with number 3 on that one. The assumptions have not been met. It's not safe to assume each group comes from a normally distributed population, but we can assume the variances are equal. Because you know what, when you looked at the video, the one guy, like, you go, oh yeah, they're okay. I'm thinking, oh man, please don't do that to me. I need to like have exactly why it's not okay. You know, I mean, I know it's supposed to be a straight line, but some of them are close. So when you statistically look at that stuff, I don't know how much variance I'm looking at to call it not normal, you know?
Well, when it was unnormal, didn't he reorganize it so that it was redone so it could be really normal once it?
Well, I'm looking at the QQ plot for,
Oh, for this one?
yeah, for beef.
You're using the inference.
No, this is not for beef. This is actually for poultry.
I just download it for hot dog nutrition.
Yes.
Okay.
Okay, so this one, what is this one for? I'm just gonna do it all, select them all. I'm gonna see which one it is. 86, okay, 86.
QQ plot. On this one.
Okay, the Q plot for this thing is, see, it's got some, it's like going straight, and then it goes up a little bit, and then it goes back on. So I'm gonna just go ahead and say that that one is good, but I don't know for sure how much variance that I'm looking for.
Hello? Hey, I gotta call you back. I'm in the middle of a quiz. All right, bye. Love you. Bye. Okay. Done.
And so this one's got some ones that are kind of out there too. So
He did something where he sorted it though. Have you sorted it?
yeah, I sorted it.
How do you sort it again? I'm forgetting.
Go to the top, and there's an A on top of a Z.
Oh yeah, yeah. Okay, got it.
Yeah.
Mine looks really straight. So
Which one? Which one? The meat or the beef or the poultry?
you're on question 14?
Yeah.
This is about hot dogs.
Right.
Oh,
They're-
do you have to do each one?
Yeah. See, that one looks off too.
Paying attention. Okay. Undo.
See, when we did the QQ plots once upon a time about 45 lessons ago,
That's
some of them, you know, they were like a little bit looking like this poultry right here. And they said, no, those are not normally distributed. So I'm going to stick with the assumption that they're not normally distributed, but we can assume that the variances are equal and continue on. That's what I think I'm going to do. Because if I go back and pull up those QQ plots that I have, that we had used from a long, long time ago, I have it all.
So you're saying that they're not in.
They're not normally distributed.
Well, I show the. Well, when that line is red and it goes through them, doesn't that mean that they're distributed?
Which one? Oh,
So what one was not distributed?
the poultry is the worst.
Okay,
So try the poultry.
try the poultry because the other ones look good. The poultry shows a straight line
Do you?
for me. Are you doing ascending or descending?
I'm ascending.
I mean, I'll share my screen. This is what I got for poultry.
Yeah, let me see.
That's my poultry.
Hang on a second. Yeah, you think that that's like this stuff up here is okay?
Well, doesn't this red line kind of show us that it is following it? I mean,
Now, the red line is the normal distribution, and these little dots around the red line, that's where you determine if it is. Well, what do you think, Rachel?
let me go back and see what.
Rachel, did you say something? Can you hear Rachel? Rachel!
Maybe she can't hear us.
I can hear you.
Oh.
Okay.
Well, are you from lowest to highest? Okay. Look at my notes. What I did on the prep.
Oh, man, too much work. Okay, so what are we gonna? You think those are normally distributed then? Okay, let's go for it. Let's say it's normally distributed, and you're probably right.
I don't know. It's not that far off. Like there have been others that are way more.
So
Okay.
are we doing the first one then?
Yeah, because I know it's definitely the variances are equal because they said that the largest, the smallest.
Okay.
So okay, now we're on number 15. Calories. So now we got to do the calories.
So is that for each of them? Yep. No, the same for all three types. Yeah.
In the Nova. So, Nova. Where's my hot dogs?
Hot dogs. Oh, have you guys ever seen a show of hot dogs being made? Don't.
Ew.
It's so bad. You'll never.
I don't like hot dogs anyway, so that doesn't matter to me.
I hate hot dogs. I limit what my kids. Okay, so I'm gonna unscreen share because you guys don't really care. Just see what
My dog likes hot dogs.
your dog. Okay, sorry, I'm getting there.
The mean number of calories is the same for 3 types of hot dogs. Okay.
We're gonna leave the other very 4, 5, and 6 blank.
All right. The mean is 156, 158, and 118. So definitely not. 118 is the mean for the poultry.
Oh, well, maybe that other question is like what you said.
That's okay though. So let's see. What does it say here? It's not the same. You should find that the degree of freedom are 2 and 51. That's right. That F is 1607. That's right. With that, the p-value equals 000. Yeah, that's right. What conclusion can you draw? So if the p-value is less, remember p-value is definitely less. We
What happened to McKady? Did she have to go?
She accepted a job. So I have no idea what she's gonna do.
Oh,
she went for that job?
The woman health clinic place.
Yeah, good
she
for
have
her.
to quit school or not do group? She could do group at night with someone. There's lots of groups.
Yeah. I don't know what she's gonna do. Because she's technically only online student. So I don't know.
Oh, is she?
Yeah. She only has classes online.
Or do you know you have classes both, right?
Yeah, I have one left on campus for this semester, and then I'll move home for my last 2 semesters. But I'll be online classes.
Oh, okay. Did you do Pathway, Tammy?
Yes, I did.
Okay, so did I.
Yeah.
I love the discount. I'm so grateful.
Yeah. Okay, so the p-value is less than, so we reject the null. So there is sufficient evidence,
Yeah, because it was 3.86 to the 6th or something.
yeah, to claim that all 3 hot dog types have a different mean number of calories.
Okay.
That's number 3.
The third one. Yeah.
Okay, so now let's examine the sodium levels. Oh, okay. That sounds fun. Let's do that.
Let's do that. I know my son has high blood pressure because he has a heart transplant, and so
Oh, wow.
he keeps showing me pictures of what he's eating, and it's like hot dogs
Ew.
and mac and cheese. I'm like, sweetheart, you've got
I wonder you have high blood pressure.
to add some vegetables in that mix. Sodium, sodium, sodium. Not good for high blood pressure.
Yeah.
I'm still pasting, whatever. Okie dokie. Oh my goodness. Okay. That's a lot of sodium.
Okay. So what do we want to know? What are they asking us?
Construct QQ plots on the sodium level for each of the 3 types. You should see the QQ plot for poultry suggests a possible problem with the normality assumption. The
Okay.
smallest variance is 7,180.75, and the largest is 10,492.871. Have the assumptions been met to use the ANOVA? Use ANOVA.
Okay, I did the ANOVA. I put them in the ANOVA. I haven't done the Q plot. Yeah, something happened? Okay. All right, I'll come back down.
Okay. All right. Let's see here.
Sorry, I'm working on. Okay.
Okay. So.
QQ plot.
Okay. Wait. Yeah.
I need. I'm gonna copy.
Okay. So I got the poultry sodium is interesting. Okay, let me see.
Okay. Did you QQ plot for that?
I did a Q plot for sodium. I'm doing one now for meat. Meat's pretty normal. And then the first one's beef, right?
Mm-hmm.
Okay. You're going backwards.
Yeah, I went backwards on it. Okay.
Isn't it doing it? The range.
Okay.
Okay. Let me grab that.
Okay, I did them all. That was fun.
I'm working on mine.
This one went, wee.
So we just have to decide whether the assumption is met or not met.
Yeah.
And normal distributed invariances.
Okay, the variances are 71.
I've got 84 on the chicken.
The standard deviation.
Yeah. And 102 for the beef.
Yes, this is right. They definitely.
ANOVA. Variance. Oh, okay, wait.
Ouch.
So it's asking for the smallest variance is 71. Oh, yeah. Okay. All the assumptions been met to use them. Oh, so it says the QQ plot for poultry suggests a possible problem with the normality assumption.
Where does it say that?
And the problem at 16, it says the smallest variance is 71. It says, second sentence, you should see that the QQ plot for poultry suggests a possible problem with the normality assumption.
Okay.
Smallest variance is 7,180.75.
Well, those
And
have
the
been
largest
met.
is 10,492.871.
So we'll say the assumptions have not been met, but we can assume the variances are equal.
Question has not been met.
Not the last one,
The third one?
the fourth one. No?
Well, no, because the variances, it has to be 4 times, right? Doesn't the smallest have to be 4 times is what they said?
Yeah.
Well, that's less than 4 times.
Oh, yeah. That's only like a third more.
So the third one or the fourth one?
I think it's the third.
Me too.
Okay. Despite
Despite the possible problems, if you see a plot for culture, you decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is the p-value for this test?
I have 0.179.
0.179.
0.1793, so yeah.
What conclusion can you draw about the mean sodium levels of the 3 types of hot dogs? Use a level of 0.05.
I think we have sufficient evidence on number 4.
The p-value is greater.
Oh,
So-
it's greater? Okay.
Yeah.
Because we want to reject the null. No.
No, if
No.
we fail to reject the null.
Fail to reject. I mean, that's what I meant.
Yeah, so we have,
So we still have sufficient evidence to claim that at least one of the hot dog types has a different mean sodium level than the others.
So the third one?
no, we don't have.
We don't have.
Because if the
second
p-value
one.
is less than
Rejecting.
Yeah.
Okay.
rejecting.
See, they're putting in words other than fail to reject and reject. So I'm just.
So the last one?
Uh,
It says we do not have sufficient evidence to reject the claim that all 3
Oh my
hot dog
gosh.
types have the same mean sodium level, right?
So the only one that says we do not is what we're gonna choose.
A second.
Okay, I'll submit it.
Wait, which one did you choose? The second one?
Yeah. I haven't submitted it yet, but
Can someone go through with me on the other ones real quick?
yeah, I'm gonna submit it to see if we got any wrong first though.
You probably get about 40 wrong on.
So,
So are we choosing the second one on 18?
Yeah,
Okay. I'll submit it real quick.
I think it's the 4th one.
well, it says calories.
So the
I didn't save the information for the calories. Wait. Because
15's wrong.
15?
15, yes. All of them have been right since 15. Yeah, 18's right. So the only one we got wrong was 15.
so 18 was right.
Yep.
We do
The
not
only
have.
one the only one we didn't get right was 15.
Okay, so 15, let's see here. So, okay, so it's just the opposite of 18.
Yeah.
So I'm trying to wrap my mind around it. Make it make sense for me. Let me take a picture of this bad boy.
Well, what was the p-value for that? Because I just left that test.
The p-value was greater than the A,
16?
than for 18.
Oh, yeah, no, I know that. But,
Oh, okay. The p-value was less than.
well, if it's less than, yeah, because wasn't it that negative number? So we have sufficient evidence to claim all 3 hot dog types have a different mean number of calories. Is that what we chose? Rachel?
We chose
Third one?
the second one.
It's the third one.
Okay. It's the third one?
Yeah.
And then so 18's the second one, right?
18.
I like just
Yeah.
Okay, so 15, so we just changed it so we can redo. Okay, so Jen, we'll get you up to speed. Number 1 is true, number 2 is true.
Got it. Number 3.
And the ANOVA, there is sufficient evidence to indicate at least one mean. So yes, it's true.
That's true.
Yeah. And the ANOVA hypothesis tests are the last 2. Data in each group are normal and variances are equal.
Okay.
And then number 5 is we construct a QQ plot to find out if they're normally distributed. And then it's 4 times the smallest variance is number 6, so number 2.
Yep.
And in this one, this was just simple. It's 6 because you have to, you test 4 samples. You 1, 2, test 1, 3, 1, 4, 2, 3, 2, 4. That one. So it turned out to be 6.
Okay.
The soccer shoes were 27.208 is the smallest variance. The largest variance is 53.158. Those are not 4 times apart, so the answer is true.
Oh, okay. Test for equal variance is satisfied.
Yeah, that means that the one is not 4 times the.
Yeah. Okay.
And then the QQ plot for those were good.
Yeah. True.
Mm-hmm. And then the p-value was 0.309. When we took off the SOC data, it turned out to be 0.309. And every time for S statistic, it's always a right skewed. It's always right skewed. We learned that in our homework studies things.
And for 14, we had the first one.
Yeah.
That's it. And the third one on 15.
Yeah.
What we're choosing new.
Yep.
Okay. Great. Thank you.
Mm-hmm. I got smart for it. Oh wait, I got one wrong.
Which one did you get wrong?
Number 15.
Again? So
yeah.
Obviously it's not that.
I gotta think about it because they try to trick you.
I know, that's why
not the third. It's either the first or the fourth.
I know. Let me think about this for a second. Okay, so the p-value is less than, right? And so if the p-value is less than, we reject the null, right?
Yeah.
And it states we have sufficient evidence to say at least one mean is different. We have sufficient to claim. Okay, that's not right. We have sufficient to claim that at least. Oh, yeah, it's number 4.
It's the fourth one?
Yeah.
Okay.
Yeah. If I would have taken time, we could have got that one right.
Are you? Yeah, I got 95. So are you going to take it?
I'm going back and taking it again. I need every point.
I know, so do I. I did not do good on the quizzes last week.
I know.
Okay.
I've got
it's 100% now.
Is it 100 now?
Yep.
Yay!
Hey. Yeah, I've got to really prepare for this test and redo everything. I just haven't, with moving, had time to.
Bless your heart. You're like moving. That's crazy.
I know. I'm
a place that's far, 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 far away.
And we're having to get our house ready for sale. My stress level has gone up like 10 times.
Bless your heart. Seriously, that's horrible.
It is. Yeah. I told my husband, this is, just so you know, super bad timing. I wouldn't have done full-time school had I known I was moving. Yeah. Like full-time, not just part-time.
Well, I told my husband you were moving, where you were moving to. And he's like, does she know?
Does she even have a clue?
No, I don't. He served his mission in New York City. My husband.
He knows how blooming cold it is.
Yeah.
So she's going to come from warm Arizona to freezing.
I know. I'm going to freeze my butt off. I won't even know what to do.
Well, you know what? Hopefully your husband's making a ton of money. You could just buy extra blankets.
A ton of extra blankets?
A bunch of extra blankets.
I'm going to need a lot more than that, but yeah.
No, he'll say, sweetheart, the heating bill was $6,000. Well, you brought me out here.
You know what? My kids love it cold. And we were in Germany for 3 months, October, November, December, and they loved it. But that's not the coldest part. It's January, February, December, January.
Well, in Rexburg, oh gosh, we call it, that's iceberg. It's cold.
Yeah, it sure is.
So it's
I've lived here my whole life, so yeah.
you know what? The back east cold is different than the cold in Rexburg.
it's like, what is it? Less cold, or is it?
No, it's humidity.
Humidity freezing, so it like gets into
Yes.
your bones more.
Well,
Oh.
you open up the inside of your coat, and there's ice chunks in them.
No.
I promise.
Oh, shoot. Are you serious?
Yeah, like
I was like, what am I getting myself into?
yeah. So it's different than Idaho cold, but you like
Yeah.
you know.
Dry cold in Idaho, and I'm going to wet cold and wet heat, and I'm used to no wet at all.
Yeah, you are used to know wet.
I'm used to
My
no-
son just moved from Houston to Gilbert, Arizona this last week.
Oh,
Wow, my skin, I feel like a lizard because it's so dry.
you know, you do. It is dry.
Yeah.
And my son hasn't complained of skin issues like he used to have here since he's been in Philadelphia area. I mean, Pennsylvania.
Wow, that's
So,
good.
yeah.
Okay, so I was explaining to Rachel, and she shared the same opinion that when we have to, from this time point, if we block off a schedule of time, we've got to stay with it
Yeah,
because you know it's getting towards the holidays and there's like lots of
everyone's super busy. We're all trying to get things done and stuff.
yeah. So we're not going to be able to be as flexible like you know the morning of saying, oh, could we change it? It's not going to happen for me anymore.
Me too. I
Me
agree.
either.
It was a little
So-
stressful to keep.
So it's going to be Wednesday, right?
Yes.
That's fine
and
with me.
on time.
We'll block out an hour and a half because it's the test prep.
Oh yeah, we took like 2 hours.
Yeah.
Well, we should. The questions are exactly the same in the like on the instructions. Those questions are exactly the same in the test. And I mean in the quiz.
I just need to really work on that really good because
Okay.
I need
You
every.
know that?
Okay, so we'll take the rest of today and tomorrow, and we'll really be prepared, try to
Yeah.
be really prepared for that. So we can take an hour and a half because I have an hour and a half, and I bet you guys do too because everyone's like crazy busy.
Yeah.
So okay, so Wednesday morning at 10 o'clock Idaho time, we'll be
Yes.
back together.